They're small, faint, and often overlooked. Floating quietly on the outskirts of the universe's galactic metropolises, they seem like cosmic afterthoughts. But what if I told you that these tiny galaxies, dwarf galaxies, are actually the key to unlocking the deepest mysteries of the cosmos? Dwarf galaxies are the underdogs of the universe. With only a few billion stars, compared to the hundreds of billions in galaxies like our Milky Way, they've been flying under the radar of astronomers for decades. But recently, something changed. Thanks to powerful telescopes and sophisticated simulations, scientists are beginning to realize that dwarf galaxies have been hiding secrets in plain sight. And those secrets? They're rewriting everything we thought we knew about galaxy formation, dark matter, and even the early universe. Let's begin at the edge of the Milky Way. Scattered around our home galaxy are dozens of faint, ghostly companions, ultra-faint dwarf galaxies that are barely visible even with the best telescopes. They look like ancient relics from a forgotten era. And in a way, they are. Many of these dwarfs formed more than 13 billion years ago, during the universe's infancy. They are some of the oldest surviving galaxies in the cosmos fossils, from a time when stars were just beginning to form. But why are they still here? That's where things get interesting. Unlike larger galaxies that evolved through violent mergers and explosive star formation, many dwarf galaxies have led quiet lives. This makes them ideal laboratories for studying the early universe. They preserve clues about the conditions that existed shortly after the Big Bang conditions that were wiped out in more massive galaxies long ago. And that's just the beginning. One of the biggest cosmic mysteries is the nature of dark matter, the invisible substance that makes up about 85% of the universe's mass. We can't see it, we can't touch it, but we know it's there because of the way galaxies rotate. And guess what? Dwarf galaxies are full of it. In fact, in some dwarf galaxies, dark matter outweighs normal matter by a factor of 100 or more. That means their stars are just tiny lights scattered through a massive cloud of dark matter. This has made dwarf galaxies prime targets in the search for dark matter. They act like magnifying glasses, allowing us to probe the invisible scaffolding that holds the universe together. And here's where the secrets begin to unfold. Take the Fornax and Sculptor dwarf galaxies orbiting the Milky Way. When astronomers mapped the velocities of their stars, they discovered something unexpected. The stars were moving in ways that didn't match predictions from standard models. The distribution of dark matter seemed too smooth. This could mean that our understanding of dark matter, its behavior, its interactions, is incomplete. Or take the too big to fail problem. Simulations based on dark matter physics predict that the Milky Way should be surrounded by dozens of massive dwarf galaxies. But we don't see them. They're either too faint to detect, or they're simply missing. Why? Could it be that dark matter behaves differently on small scales? Or is there something about galaxy formation that we still don't understand? Then there's the curious case of star formation. In some dwarf galaxies, stars formed rapidly in the early universe, and then stopped abruptly. Others show a slow trickle of star formation over billions of years. Some are full of gas. Others are gas-poor. No two are exactly alike. These quirks challenge our models of how galaxies grow and evolve. But perhaps the most astonishing discovery came from the Hubble Space Telescope and its successor, the James Webb Space Telescope. By peering deep into the cosmos, they revealed faint dwarf galaxies in the early universe, some just a few hundred million years after the Big Bang. These early dwarfs were forming stars at an incredible pace, lighting up the dark universe like cosmic lighthouses. Their light played a crucial role in reionizing the universe, transforming it from an opaque fog to the transparent cosmos we see today. In other words, dwarf galaxies helped turn the lights on. And yet, for all their importance, many dwarf galaxies remain hidden. Some are so faint that they blend into the background noise of the sky. Others are shrouded in dust or drifting in the far reaches of intergalactic space. Detecting them requires careful analysis and the keen eyes of astronomers who know where to look. New surveys like the Vera Rubin Observatory's Legacy Survey of Space and Time are expected to uncover hundreds, maybe thousands of new dwarf galaxies in the coming years. Each one could offer another clue, another secret, another piece of the puzzle. So what does all this mean? It means that the universe has been whispering its secrets to us, not through the grand spirals of massive galaxies, but through the faint hum of these tiny dwarfs. It means that to understand the cosmos, we must look not just at what shines the brightest, but at what hides in the shadows. Dwarf galaxies may be small, they may be faint, but they are powerful keepers of cosmic history. They hold the stories of dark matter, of the first stars, of galaxy formation, and perhaps even of life itself. Because if these galaxies are as old as we think, if their stars formed when the universe was still young, then they might also hold clues about how the first planetary systems came to be. The next time you look up at the night sky, remember, some of the universe's most profound secrets are not hiding in distant quasars or supermassive black holes. They're drifting quietly, in plain sight, inside the tiniest galaxies we almost forgot to notice. And now we've started to listen.